Welcome. In this video I'm going to show you how you can perform a Bhapkar test using Python 3, and specifically I'm using Jupyter Lab. Now this Bhapkar test is something you can use if you have two nominals that are variables that are paired, so they are sharing the same categories. There are actually then two options. If you're only interested in the overall distribution chain, so if the percentages from each category changed or not, then there are two that seems quite popular actually, and one of them is the Stewart-Maxwell test and this Bhapkar test. So I'll be using the Bhapkar test because according to Ubersax, that was actually preferred. Now you can also check for changes. If the changes are symmetric, in other words, if the number of people who switch from for example from A to B is the same as the number of people who switch from B to A, then you will need to perform probably a McNemer-Bowker test, and I'll discuss that one in a separate document and a separate video. So to show you how this works, I'll need an example, and that example I'll load as a pandas data frame. So I'm going to import pandas. If you never used pandas before, then you first need to install it, which could probably be done with an ! pip install pandas. That goes for any packages or libraries. We then need to load the data using read CSV. So nominal paired is actually the data that I'm going to be using, and my df head will show me the first 5 records, and we can see before and after. So people could choose between a few different brands, perhaps before and after seeing a commercial, which one they preferred. We begin with creating a cross table of these two. So I'm going to use crosstab from pandas, and that nicely gives me an overview of all the counts. So these 3 people, they before they select brand B, and after they selected brand A. So perhaps after seeing all 3 commercials from the brand, they decided from, hey, I no longer prefer brand B, now prefer brand A. The only package I could actually find that works and that performs a Bhapkar test is the Stats Models API package. So, and it's actually part of the square table. So I'm going to load that in. And then the function will actually want a specific type of this cross table. So it has its own function square table, which will do something with my original cross table. And I'm also applying the shift zeros equals false. By default, that's set to true. What it does is if it's set to true, this 0 will become a 0.5, and that gives a slightly different result. Now I've looked in programs like SPSS, and also there's a special software tool for specifically this test, and they always do it with the zeros equals false. Took me quite a long time to figure out that this was causing the difference here. We can then use homogeneity and then method equals Bhapkar, and that should give us results. It tells us the degrees of freedom, which is useful if you're going to report these results. You can check my website a little bit on how to report these results. The p-value, which is the significance sometimes called, and it's important if that's usually the threshold is 0.05, well in this case it's far below that, so it would then be considered normally significant. The statistic that's actually being tested, that's actually a chi-square distribution, so if you ever want to check, you can fill out a chi-square value of 15 point and then all this with a degrees of freedom of 2, and it should give you this same p-value. So the chances in this case very low, so that means we reject the null hypothesis, and then the assumption about the population is probably not true, so that means that there are, in this case, changes. In the appendix I will show you how you can actually avoid using stats models and go over the formulas, but in essence that was basically it. Here are the references that I've used, and just to quickly show you the hard way, as I call it then, and when I go really over all the formulas, I need the proportions, so I changed my cross table to proportions. The column totals and the row totals need to be stored. Then we calculate the differences between those for each row and column matching. Then we need to do all of this, which is for the diagonal different than for the other cells, so that's what's being done in all of this here. Then we'll need the matrix manipulation, so I can use NumPy for that. The inverse of that S, we also need to transpose that differences, and then we can do some matrix multiplications there, and then finally we get that same chi-square value. The degrees of freedom is the number of categories minus 1, so that gives us hopefully that 2. We can actually see that. And then we also need a package to convert the chi-square value to a p-value, and there we have the same p-value. Alright, I'll leave a link in the description. This is a small alternative for the matrix inverse. I'll leave a link in the description below to this notebook, so you can nicely go over it yourself at your own pace. I hope this video was helpful, and thank you for watching.